everyone, and welcome to yet another webinar session organized by Factana Computing. We really appreciate and thank everyone present for taking the time and joining us in this webinar session. A quick brief on today's topic, which is, as we know, Industry 4.0, harnessing IoT and AI for efficient maintenance services. At the end of the webinar, we will be able to know how IoT and AI helps in maintenance services, how to integrate IoT with Fogwing Asset Plus for metering. We will also be exploring maintenance checklist recommendation engine, and cherry on the cake would be the value driven by AI and IoT together, among the other topics that will be covered today. My name is Shweta and I'm part of the marketing team at Factana. For those who have been part of our previous webinar, we are glad to have you back. And for those joining us for the first time, I would like to take a moment to provide a brief introduction to Factana Computing and the services we offer to you. So Factana Computing is a leading provider of solutions for Industry 4.0. We have been assisting numerous small, medium, and large enterprises in their journey towards adopting Industry 4.0 and digitizing their manufacturing operations. With a global presence, Factana operates in India, Europe, and the USA. So let me quickly summarize our range of product suites for you. Fogwing is an industrial cloud that offers a wide range of digital solutions tailored for Industry 4.0. The Fogwing IoT platform enables seamless connectivity with machines and assets, facilitating efficient data aggregation. Introducing Fogwing Asset Plus, a comprehensive software solution provided by IoT and AI technologies, designed for asset performance monitoring and computerized maintenance management system. Our S-Factrix AI software serves as an intelligent manufacturing execution system, digitally transforming shop floor operations to enhance operational efficiency, ensure quality compliance, and maximize return on investment. For on-premises data processing, we present the Fogwing IoT Edge, an industrial edge device integrated with AI capabilities. Additionally, we also offer Fogwing Eco, an air pollution monitoring solution that includes both hardware as well as software for industrial pollution monitoring. So that was about our offering. Mr. Hariharan Ganesh, who also is the founder and chief architect at Factana Computing, will be presenting us this webinar today. Before getting started, a quick note to everyone. If you have any questions, do not hesitate to ask. You can shoot all your questions in the Q&A box, which will be answered towards the end of the webinar session. Also, a recorded session of this webinar will be uploaded very soon on our YouTube channel. And for those who will be watching the recorded session of this webinar, do not hesitate to post your queries in the comment section of the YouTube channel as well. We will be happy to take them. So without further delay, let me quickly hand over to Mr. Hariharan. Over to you, Hari.
Thank you, Shweta. Hello, everyone. Good morning, good afternoon, good evening, wherever you are watching or connecting this session. Glad to have you here. And this is an exciting topic as we are going through a lot of transformation across industry. Two major, technology or most advanced technology available today for the industry users to apply those technologies in a different aspect of that and get a value on that. Today we are presenting about in IoT and AI and how both adds value to the maintenance. But before getting into that, just to bring all of us into the common understanding about what is what. Here is the just a quick view on that. IoT is of course you would have heard that, but IoT in general are foundation of the network of connectivity. So basically, it's help us to connect to the physical systems or physical objects which we could not connect earlier, and try to understand what is happening on the physical system aspect of that. It's more for communication purpose, data aggregation purpose, and sensing the information from the physical assets, which predominantly machines in the industry cases. So there are two category or broader category of IoT. So one is consumer side as well as industrial side. And we at Facton are focusing more on the industrial side rather than the consumer side. But of course, the technology can be applied in a different aspect of that. On the artificial intelligence is most advanced analysis model and logical model with a learning capability, which can help us to make a decision faster or give more accurate decisions itself. So there are many variants on that, from the reactive AI to general AI, all the way to the self-awareness or self-sufficient AI. So there are various versions on that, or various models on that, which applicable to specific industrial or problem solving use cases. Now, I think, last few years, there is a significant ramp up on the technology adoption, especially IoT and AI technology. Both are, playing a major role, and of course, different level. But here is this quick snapshot of how the industries are adopting the technology. If you look at in the IoT side, manufacturing, and oil and gas, healthcare, energy are the most top adapter of IoT technology, because that's where the physical systems are involved, especially manufacturing or gas and oil companies. A lot of physical assets are involved, which usually not connected, but now it's the new technology allows us to connect to them and then get the information about their working conditions. Whereas in AI is being widely adopted in a different scale, mostly on the computing technologies as well as the healthcare, financial services. But what we are seeing now is the change happening at the manufacturing or industrial cases, where the level of AI adoption is increasing significantly, more than 300%, and that results in more intelligence added into the physical nature of the system. So, so with that, since our context is more on the industrial operation side of that, there are few purposes that can be achieved with the help of IoT and AI. As we saw that, IoT is more on the connecting to the physical system, aggregating the data from the physical systems, such as machines. It also helps us to monitor the mission, because when we are reading that, sensing the information about our condition of the mission, obviously we can understand how it operates. So it helps us to monitoring it. Also, when you have a physical or even you have a digital connectivity with the physical systems, there is an opportunity for us to control that missions from remote place if it is required. As I know, a lot of remote missions assets are there in the remote locations, which physically we don't need to travel. Usually a lot of engineers travel to the place to control it or operate it, but we could control that from the remote locations. So there is a controlling options available now with the help of Internet of Things. Also, if you want to add or update some kind of a firmware, or you want to update the mission's intelligence or kind of operating model, you want to update anything on the mission level, which can also be done with the help of the Internet of Things or IoT-based connectivity. So by connecting to the physical missions, we could achieve multiple needs or operations and improving the efficiency of the mission performance. On the other side, artificial intelligence, helping us, because we are collecting the data from the missions, but we need to know that how that data is being process the data and understanding what is going on at the mission level. So for that, we will leverage the AI technologies such as machine learning, which help us to understand the data that's coming from the mission and predict certain value which can occur in the future. So based on the current data production versus previous incidents, we can identify predict what is going to happen in the facility or in the mission conditions. Also, technology like digital twins, which is a combination of physical and digital nature, which help us to simulate the behavior of the machine by increasing the speed or velocity or or the energy or power or reducing the power, we can simulate to understand what could happen if you try to tweak the machine in a different scale and parameters. And that helps us to simulate the data and see what is happening, what could happen if we do some such kind of a process changes or machine conditional changes. And the last one is automation, just giving a self-intelligence, like, self-drive cars, right? So similarly, giving a self-intelligence to the machines or the controls. So whenever, if there is a significant condition, the machine can take a call of that, such as if there is a fire inside the machine, and there is a way to, if we add an intelligence to the machine, and it detects by itself that there is a fire inside, and it can stop the performance, or it can control the fire, or it can stop it by itself. So instead of continuously operating and leading into more damage to the physical assets. So such kind of automation can be done with the help of intelligence. So both are playing a crucial role, both are tied together. IoT is for connectivity and allow us to reach the mission, physical missions. AI is basically adding intelligence to that, so that the combination of that adding a bigger value to how we operate in the machine levels. Since this particular webinar's context is more on the maintenance service, I have a different view on that. Just a little drilling down into that of how IoT and AI can add value to the maintenance services. Maintenance service is more on going to the physical machines and doing some checks, inspections, checks, and preventing certain kind of damages to the machines, and continuously doing that. It's ongoing services, right? So with the help of blending the DNA of IoT and AI, and we can get a sense of the machine condition from anywhere. Also, we can add a physical intelligence to that decision-making process in terms of the maintenance services, such as connecting to the physical machine, capturing the metering data. Metering data is the data that we usually go on. The engineers will write it out or note it down using pads and other things. And they measure, like, okay, what is the vibration level? When I'm visiting the inspection, they make a note on that. What is the vibration level on that? And what is the temperature of the particular motor or inside the motor? What is the energy consumption of the particular engine? So they capture this information as part of the metering capturing, and these data are later fed into the machine systems and do some kind of a calculation to understand what is going on that. But it's required physically we have to visit, which can be avoided with the help of Internet of Things, and that's what we are going to see later in the day. And then they understanding the machine health parameters. By using sensors, we can detect the machine vibrations. So the more vibration, and we understand that there is a vibration happening, more vibration happening, we can do the plan and execute the maintenance services more appropriately. Sometimes we don't need to necessarily go and do the maintenance service, which is not required for the machine. Sometimes the machine is overloaded or overrunning, and which requires a more frequent maintenance than previously expected. So such kind of decision, that's kind of information which we can capture with the help of vibration or usage data. So that helps us to understand the machine condition on and off, and whenever required. Also shut down the machine if there is a issue, as we saw that. And then tracking the machine location. Sometimes the physical machines may be moving machines, which moving across the inside the factory premises or outside, on the transportation level. So we can track that where the asset is there, what is the condition of the asset, and when that required a maintenance. Such as logistic and shipping services, we can and related maintenance. We can track that where the truck is there, and then how frequently the truck is running, how long it's running, and what is the temperature inside that engine, and what is that any abnormality in the engine level, so that we can direct the truck to nearby maintenance service location to fix it before it break down in the middle of the road. So such kind of use cases can be addressed using Internet of Things. And of course, it's not just data collection, it also depends on the artificial intelligence. So the most important thing, or basic thing in the maintenance, is the checklist. Basically follow the maintenance steps to do the maintenance of the particular physical asset. So we can, so this is usually, based on experience level, the most experienced maintenance, engineer who could, clearly define the checklist for the follow-up on the maintenance service. Whereas, if you are onboarding a new team members in the maintenance service and they may not aware of the checklist procedures properly, we need to hand over to them the checklist. So such checklist things, right? So it is always a knowledge that we gain on this. So that generating checklist could be one of the use case. With the help of AI, we can generate a more efficient checklist and hand over to the junior level engineer so that they can follow the procedures properly. And second thing is on the prediction. Predicting the abnormality. Of course, the data collected by the IoT, but the prediction is happening with the help of AI. So the AI can identify that, if something goes wrong, such as anomaly detection. So, and then, it can identify that trend, and based on the trend and usage and other conditions, and it can give that the information or alert to the engineers, maintenance engineers, so that they can go and look at the issue. And then the automate the maintenance process. Sometimes, we are not nearby the physical missions, but of course, maintenance engineers are busy and they are moving across different sites to fix certain things. And obviously, if one of the machine in some location is going through some abnormality, and we have to prioritize the mission maintenance activities. So some of the assigned work orders or the maintenance task should be prioritized based on uncertainty happening on the day or within the day, and it happens in real time. So such level of automation on the predictive maintenance or maintenance schedule could be achieved using AI and IoT technology together. And finally adding a self-intelligence of self-corrections, like if oil level is down in a particular engine, and there is a auto oil filler attached with the engine. So whenever the oil level is down beyond certain limit, and the system itself, without going through all the cloud level communication, the engine itself will give instructions to the oil refilling, to fill it by itself. So whenever the oil level is going down, it's filled by itself. So that kind of a self-intelligence can be added with the help of AI-based models, and that helps it. So the combination of IoT and AI add a lot more value to that, and it cannot be break apart, because both are equally important and must work together. That's why we call it as a hybrid model, where we are combining the Internet of Things and AI together in our platform solutions to give more comprehensive value to the maintenance services. So if you're first time you are attending this session and you are not aware of Fogwing Asset Plus, and Fogwing Asset Plus is our maintenance management software or the computer CMS software, which combination of two things, and that it's of course maintenance management is the primary scope of that software solution, but in addition to that, there is a inbuilt performance monitoring with the help of IoT, where we can detect the machine performance and things. So it's a combination of that, and there are various features. We can categorize that as a work order management, asset management, asset related information management. That includes metering and asset checklist. Then part of the parts management in terms of parts or inventory that we need to go and fix it on the problems, and the stakeholders management. So there are four broader category that are modules that we can together. In this session, we are going to look at the asset metering and asset checklist functionalities of this platform solution. But there is a common question, oh, we know everything, that how we can, how we should go and fix our machine. So I don't need a checklist. I don't need to do that because I know everything. I've been doing this for 10 years, 15 years. Of course, it is good. It's of course you are the expert on the machine that you are maintaining it. But eventually, it's all about the team management, team building, and the knowledge management. So sometimes any human, how much experience, we missed out certain times because of the environmental situation, personal situation, things like that. to ensure the maintenance service always happening in a proper standard, regardless of the experience level of the engineers. So we have to bring some standardization on that, so that make sure that people are following that across the skill level. So standardizing the maintenance procedure is the most important process, and allowing the organization to to keep the knowledge and also to manage the consistency of the efficient maintenance, regardless of the level of skilled engineer deployed on the field. So standardization is very important. And also sometimes we need to cover it based on the conditions. The coil was burned last month, so now we are going for next maintenance, and there may be some additional step that we need to do that to make sure, hey, we fixed some new coil last month. Now it is it good condition or not? Is there anything on the physical side of the coil? So do we need to check that out? So this may be change in the procedure, but that needs to be covered on that procedure list, so that it is not missed out by oversight. So ensuring comprehensive coverage on the steps that we involved, and especially if you are running a maintenance service and you have a plenty of clients and where you need to go and do the frequent maintenance service. And obviously in that case you should have the standard procedure, because every day your engineers are going to see a different machines or different physical systems that they may not able to remember all of them what they need to do that. So they should definitely need a coverage to meet your SLA and your commitment to your customers as part of your maintenance service solution. And inconsistency, to avoid the inconsistency, quality of checks, errors, oversight errors, and the knowledge management. As I said, knowledge management, communication, giving to this information to either experienced engineer or a junior level engineer. The output should be consistent. So to make sure that both are doing the right way, especially the junior engineers, so we need to manage the knowledge. This, by bringing a system where we have the checklist, is helping us to maintain the knowledge on the system level rather than human dependency. And then supporting document accountability in terms of management projections and usage metrics, also to provide any compliances, regulatory compliances, where you need to capture the, and then you need to show to them that you are following that, such as carbon footprint monitoring, or if the organization is committed to the low carbon, low pollution, and they need a consistent maintenance service to make sure that the pollution level is lower. And this is one of the important checklist that they should follow, and they should present it to the compliance board that they are following the procedures defined as per the organization standard. So checklist is very, very important step to enforce or to to apply the standard across all the maintenance service, especially for the company who is specialized in providing maintenance service to the third-party customers. So to facilitate this critical step in terms of the maintenance service, so we have introducing a new checklist recommendation engine with the power of Open AI, the most powerful generative AI system available today, where we are as part of our systems, we are providing a option for users or the manager to go and create to get the help of the OpenAI to identify the checklist. It's basically a recommendation engine. It's not enforcing it. It's manager's decision to pick and choose which checklists are meaningful, which checklist may not be required for my system. So so they can pick and choose. It's a recommendation engine, but once it is selected and applied to the system, then it will be followed by the engineers. So the recommendation engine works in such a way that the system communicates to our servers, and internally we communicate to the OpenAI. So there is no technical involvement from the maintenance service standpoint. You don't need to have any technical knowledge in terms of the AI or how to generate or how to use the OpenAI or how to generate things. So we take care of that. So we provided a simple format where you can just go and query that, and based on your query and your system or asset that you wanted to do the maintenance, you get the recommendations from the AI engine, generative AI engine, and based on that you can do that. So that's how we have created it as simple as that, and make it more simple for our maintenance folks to apply this technology without worrying about how things are happening behind that scene. To enforce the standard operating procedure, right? To enforce that SOP or maintenance checklist in our systems, it's a 3 simple step process, and of course there is no coding or scripting is required. So the step 1 is to declare the asset. Obviously you need to declare the asset. What is the asset that you are going to do the maintenance, what kind of asset and all, and you need to declare the asset as part of the asset inventory. It should be there in the asset inventory. And then once it is declared, then you can go to the checklist engine to create a checklist for that asset or that category of assets. So you don't need to choose a specific asset. You can just choose the category of the asset, so that that the standardization is coming into that. So you need to create a checklist. Once you have created the checklist, the asset is available, checklist available. Now you are going to create a work order for a maintenance. And you must create a work order. While creating a work order, you select the asset. You also select the checklist that you generated with the help of the CRE, the checklist engine. So attach it and then assign to your engineers. So when you are assigning to your engineers, they see that which mission they have to go and do the maintenance service, what kind of service they have to do that, and they also see the checklist. And you can make sure it is mandatory for them, so they follow the checklist, and they may not be able to complete the work order without completing the checklist. So that's a step 2 on that, or step 2 and step 3 on that. So once they complete once they assign it, they go to the field and they follow the checklist, they execute the work order, they follow the checklist, and they make sure everything is properly check marked. And once they submit it, it becomes a certified work. Until the checklist is not completed, it is not a certified work. So based on that, you can follow the compliances, and these certificated work could be helpful to prepare a report and submit to the management or compliances purpose. So let me take a step back, and I'm going to show you on how we can follow these procedures. As simple as that. It's going to take hardly 5 to 10 minutes to define it. Let me go to the application. If this is the first time you are watching this this webinar session and you have not aware of how Asset Plus is working, we have hosted our previous webinars, and we have a complete demo is available in our YouTube channel. You can go and look at in our YouTube channel, where you can easily find out the full demo of our introduction of the Asset Plus CMS system. For this, based on the timing, for this context, I am going to quickly jump into the asset declaration, checklist creation, attaching that work order, and then showing how the execution can happen. So as soon as you land in the dashboard, this is our Asset Plus application. You have to go to app.assetplus.ai, and you need to, if you don't have account, you need to create account. If you have account, you can log in. As soon as you log in, you see the dashboard. So very simple thing is, first we need to declare the asset, right? That's the first step. So go to the asset section. You can create asset. So I already have some of assets here. So if you want to create asset, let's take, I'm going to create a new asset for, oil pump. Okay, so I'm creating new asset, oil pump, generating code. You can, you can have a category. I already have set of categories. So now I'm going to create a new category. So pump. Okay. Pump. Okay. Then just declare it. So it automatically creates it. You don't need to do anything else. You can just simply create asset, and you can start using it. So the plant I can use. Okay, I have a plant. I can choose the plant also if required, just to give more things. So now I have created the oil pump as asset, as simple as that, simple fields. But if you want to add more and more specifications into the asset, you want to capture like, running time, you want to capture about the brand, other things, you can still go ahead and fill it up, but it's not mandatory. You can simply create asset and use it. Or if you want more comprehensive asset information here, then you can use the spec and all. I will talk about the metering later. Right now, let's go with this, with the checklist engine. So I have created the asset. Now I need to go to the checklist engine. So to go to the checklist, you need to go to the settings page. Okay. And then you need to go to the checklist engine. So to go to the checklist engine, you need to go to the settings page. Okay. And then you need to go to the checklist engine. So to go to the checklist engine, you need to go to the settings page. Okay. And then you need to go to the checklist engine. So to go to the checklist engine, you need to go to the settings page. Okay. If you're admin, you will have the settings. If you're an engineer, you will not have the settings because engineers may not have the control on that. Only the manager, supervisor, admin level, they have access to the settings. So now go here, and then there is a checklist called, there is a option called checklist, and go to the checklist. Now you are going to create a checklist. So the first step is to create a checklist for the oil pump. So I'm going to declare it. Okay, you identify by itself. I'm saying that oil pump inspect. Okay, inspection checklist. So and then category is pump category, and then I'm saying that oil pump inspection checklist. Okay, you can make it mandatory or non-mandatory. If you make it as a mandatory, then it will be enforced by the work order. So the engineer cannot complete the work order without completing the checklist. But if you are giving a checklist as just a reference point, you don't want to enforce it, but you just want to give the checklist as a reference point, you can disable it. So it won't push the engineer to complete the checklist, but they can still see the reference as a reference. Okay, once you are submitting this, it's create a basic heading level information. Now you need to create the checklist items. So you can manually create a checklist item by clicking this checklist. Let's take, I'm creating one open cabinet. Okay, that's the first checklist. Question is number 1. Okay, so now I have created it. You can manually enter it, of course, if based on your need, and it automatically adds a checklist here. But if you want to use our AI engine to generate it, so let's click on this button. So get the help of checklist recommendation engine, and then go here, and then you can type, based on your asset name or brand name or type, right? So I am saying that oil pump. Okay, let's see what is coming up from our engine. So this makes communication to the OpenAI platform to get the recommendations from that, and you should have a credits to do that. So there is a credit available here for me in my account. I already have credit. If you are using a pro account, you will get a default credits. And if you want more credits, because you have a lot of assets and you want to create more credits, you can purchase more credits and then you can use it. So right now, I'm just clicking this search option. So it's basically going to communicate to the OpenAI engine. So it might take up to 1 minute, depends on how the OpenAI engine is busy and the process is taking time, based on the brand or the type of the asset also, because sometimes if too many number of checklists are available, then it may take some time. Yeah, that's what is happening now. Let me try again. So it's taking more time because of the oil pump. Maybe it's taking too much. Okay, now I got it. So in this case, now I have recommendations from the OpenAI engine. Everything is coming from the engine, and we are just prefilling everything with the numbers and the orders. So you can see here, check the oil pump for any visible sign of damage, and verify the oil pump compatibility, engine model and type, and inspect the oil pump. So I'm just seeing, some of them. Oh, these are all good. Okay, I will go with that. Either you can say, you can select all to check all of them, or if you think some of them are not relevant, you may select all and then go to the bottom. Oh, this is not required. I don't want to do this. It's not nothing relevant to us. So I can remove it. So once you're removing it, so I have 9 checklist items. Now you submit it. As soon as you're submitting it, it automatically adds everything into the list. So now you can see the list added here, including the one that I added manually, and then all the checklist added here. So this is how the checklist can be created, easy and fast way, and based on the category level. So now you can apply that in the work orders. So now I have created oil pump inspection checklist. Done. So the checklist is added. So I can see here, if you want to see here, it's not mandatory, but if you want to go, and you can also see that list of things are there. So if you want to edit a specific one, let's take, you added by mistake and you want to remove it, you can still remove that by clicking this button. You can delete this this particular checklist item from the list. If you want to modify it, you can continuously add it. You can add even more also. If you think a particular case you want to add it more, you can add it as well. As many number of checklist items you can add it. Now let's go to the work order. So work order creation is very simple process. So you can go to the work order page to create it, or you can also create it using here. But this is a quick work order creation option where you may not see all options, including the checklist option. But if you want to do the checklist option, then you need to go and create a work order here. So here I'm generating work order. So I'm saying that, okay, oil. Okay, I'm saying that EAT oil pump. That's my location. Click inspect. Okay, inspection. And I'm selecting oil pump. Low priority. I'm not worried about these things. Oh, maybe I can select the target date as today itself. Okay, so work order type is on demand. Okay, here the checklist. So now you can see based on the category that you have selected, this oil pump belongs to the particular category. You are seeing the oil pump inspections checklist. Even though there are other checklists you would have seen in my screen previously, because they are all related to other category of assets. I select the oil checklist and then I'm sending it to Martin. I can project it like, this inspection might take 2 hours one day. So I'm just estimating it. So this is how I can create a work order. Okay. So now the new work order is created. And the new work order is created in the last. Okay, so the new work order is created as of today, and it is on the open state. Now I want to execute the work order. So either Martin can log in his own account and he can log in and do that, or if I'm the person who in both, I'm the manager, but I also do the engineering, maintenance work, and this is assigned to me. Then probably I can simply prefer here to do that execute work order. So I go here and select the execute work order. As soon as you go in and seeing the execute work order, you will see the work order, instructions, inspection, work order, what asset, and things like that. And also you can see on the right side the checklist, which I have, created just now to enforce it. So now the checklist is here. Since it's not a mandatory checklist, I can simply, complete it without even selecting it. If it is a mandatory, they must select all of them. Okay. Now let's take, I have completed my checklist. You can go on progress base, in progress, if you're starting the work, and then you can on hold if it is something is, you are holding for it, or you can directly complete it. So I'm just completing it for simple demo purpose. Let's say now I worked over 2 hours. Everything is good. Okay. And then, of course, I have to, compliance with the checklist. So I can select the checklist. Okay, one by one, step by step, they can do that. They can submit it, or they can, go and cross check that. Okay, I have done this. Okay, I have done this. I have done this. I've done this. Everything I have done it. Okay. Now I agree that I have completed all the steps as mentioned in the list. Then submitting it. That's it. The work order is completed now. So this work order, I think it should be there here in the last. Yeah, so oil pump work order is completed. This is the work order is completed. So I'm seeing all the work order is complete as per the checklist. When I'm going here and view this, this work order, is saying that, it's following the checklist and all. And then, I can also go and check in the asset level. Let's take, in the asset level. There is a place called APM, so where you can go and check. Oh, not this one, sorry. Oh, yeah, that one only. So I have completed one maintenance history. There is no metering at all. There is no other information here which are getting populated because I have not completed it. So once I am completing the metering, then you will see more information here. As of now, I have done one maintenance history for this new asset with a checklist, and it is already done. And then the total cost we spent on this particular one based on my hourly rate and things like that. So that's how the work order execution simply done within the 5 minutes time. To create asset, create a checklist, apply the checklist, and do the work. Of course, maintenance work will take 2 hours, but within that 5 minutes time, you can set up the system and up and running with that. Now let's talk about now I'm moving into the IoT case because metering is very important as well. So we are solving the second problem, which is a metering problem. As we looked at that, metering is more of manual work so far traditionally. People has to go to the physical machines, see the manual metering and reading the data, or even if there is a digital meter, still they have to go to the physical location, make a note on that, and then come back and enter in the system, and then store the data and process it. With the help of IoT, we can automate it by connecting to the asset through the IoT process directly, and start reading the data without even going to the physical location. So with IoT, you can get the real-time data instantly from the asset, or you can schedule it as a batch. If you want to read only 4 times in a day, you can batch it, or you want every minute data, you can also batch it. So it depends on how you are implementing the IoT solution. And also, you get a more accurate data because it's all coming from the machine directly without any human intervention. So it's the data accuracy is very high. And using this data, we can understand the abnormality of the machine and proactively do the maintenance activities. So how our platform Asset Plus is working on this. So as you would have seen that in the beginning of this session, we are a company providing IoT device management platform as well as the maintenance service. So we have 2 different products on that, but it's all work together. Our products are integrated products. So all of them work together in a specific use cases. So here we have a complete no-code IoT platform where you can declare and create a device and then connect the device to the IoT device to the machines and start reading the data. So the way that it works, if you are a Asset Plus maintenance manager or maintenance engineer, and you may not you have only Asset Plus as a account access. So what you can do, you can go to Asset Plus, and then you can go to the enable the IoT option. And once you enable the IoT options, you can go and create a device registry. You have to declare the device, and you have to connect the device to the platform so that the physical device, the IoT device attached with the physical machines could communicate to the cloud, to our cloud, and that data comes back whenever the sensor reading the data, or the device, the IoT device is reading the data from the machines. It passes the data back to the cloud through our Fogwing platform. That way, data reaching the Asset Plus information. So we need to do this mapping. It's again, it's just a 5 minutes work only. It's nothing major except the physically, you need to go and connect to the hardware configuration. So that's a different perfect. From the cloud standpoint, it is just a 5 minutes work to set up. So let me show that. I think that's, yeah, let me go back. Let me show that in our system. So for this case, I have already done the IoT connectivity. So let me go to the settings. If you are a manager, then you are admin, you have access to the settings page. Again, engineers will not have access. You have to enable this option. This option is available, so you can simply enable it by subscribing our model. So you go to IoT devices. So once you reach IoT devices device provisioning section, you have a device registry as well as you have a device edge devices. So for simplicity, I already have declared a device. Let's take I have a boiler machines. Okay. So I have boiler machine which is already connected. So the way that I have created is I go here and then I create a edge device. Let's take in the Asset Plus. So declare the UI and type is controller. So I'm saying that let's take oil pump. Okay, that's it. Oil pump position. Yeah, want to know the position. Okay, that's it. Device is registered as simple as that. So you can see the activation code here. I can enable, copy this for record purpose. And then I have to activate it. So I need to activate the because it's right now it's in the registry. It is not it's not physically available. It is in the registry level. So I can activate it. Once I activated that device, then activation is happening. Then it becomes available in the available devices. So you can see it's unconnected, right? So now I have device ready for provisioning. I mean, ready for access. So I go to here and click on MQTT access. And this portion, you may need an IoT engineer or your engineer help to understand this. If you are a maintenance manager and you are not aware of the technical side of this, you can hand over this information to your device configuration party, vendor, or your internal engineer who can configure it. And we can send, you can connect your own devices to send the data to the cloud. You don't need to, it's device agnostic, so you can connect any devices that you are available in the market. You can buy, connect to your machines, and take the data and send it to a cloud. So this basic MQTT information available for you to connect it. So I have already configured one of the device in my MQTT. So just to simulate it, this is a tool that I use it for communication purpose, as if the physical device is simulating the data. So you can have this information and copy this information and configure in your devices configuration page. It should be depend on the device that you are using it. You may use industrial grade devices from Honeywell or somebody, or you may use a simple custom devices you built on Raspberry Pi or ESP32 or anything like that. You can use, and depends on the device provisioning how the MQTT connection is there. But all information that you need to configure is available here. You can take it up and connect it. So once you are connected with that, so let's take, I have a boiler one that I already connected, and it shows it's connected. Now I am going to simulate a data as a temperature. Okay. Before do that, I will also show the metering page, so that okay, there is a previous record that we created at 155 record reading from the temperature from the boiler. So this record shows that meter reading from the boiler at 155 degrees centigrade. So now I'm going to simulate it in a different number. So let's do that. I'm saying that 110. So I'm sending a simple text, simple JSON format message from the device to the platform. So simply publish it. So as soon as you are publishing it, the data should appear here. Let's wait for 2 more seconds. It takes up to 1 minute to appear the data. So previous data. Okay. Still waiting to appear. It's went through. Yeah, it's published. Yeah, now it's appearing. So I simulated your data from the MQTT box, which is a physical simulation, message simulation. So this is basically simulating how the data comes from the missions, and that data appearing here. Now, this is how the data comes here using this. To enable this option, you need to go to the, you need to do only one step, which I missed out to mention. So this is how the data comes in, but to enable it again, once again, I'm going back to the IoT device page. So you need to come here. Once you have access is enabled, you need to create a device registry, and then you need to activate the device so that the device appear in the devices section. But if you have to do that, you need to create a connection to the IoT platform. For that, there is a settings here. You need to provide your information. And once you provide it, there will be API key generated, which I have already created it. Of course, after this webinar, I'm going to delete it. But this API key can be used to integrate the two platforms together. So same way, you need to do that API key generation first before you do the action. Otherwise, this option will not be enabled for you. The add device option will not be enabled for you because you have not configured the basic connection. So if I go back to the diagram, there is a connection here. The key should be there to make the bond between these two applications. And for that purpose, you need to do that. So now if you go to the asset, let's take, I simulated this asset only. So yeah, I can see that, last meter reading is 110. And you can also see that, the meter reading for this particular asset, the boiler mission, my previously simulated data are coming here. So this is how the data comes in. So you don't need to physically go there with the help of IoT. You could read the data from the missions, and you can see the latest data and what is the trend and things like that. There are a lot more things to show here in terms of these metrics, how the data is coming, what's the performance of this metrics data, and the things which we will show it in the next webinar session, as we have exclusive metrics and reporting sessions coming up. So where we will show more detail about this asset, how this data can be used to make decisions and things like that. Going back to the session. So what we are bringing to the table for the maintenance team, we are standardizing the maintenance operations with a set of procedures through our highly intelligent checklist recommendation engine, and it's easy, quick way to set it up, and then enforcing the SOP across organization to follow the standard and compliance with that. We automate the meter reading through our IoT connectivity, eliminating human errors. So all the data capturing is happening from that from the physical assets to our platform through our Asset Plus system seamlessly with our IoT platform itself. So you can connect your assets and send the data directly to our Asset Plus, and that will be useful for maintenance team to review the data and take actions on that. And also, everything we are providing as a no-code, low-code product, and also low-cost model on a monthly subscription basis. So you don't need to invest anything on the AI. You don't need to invest anything on the IoT platform side of that. All you need to do that is, subscribe to our platform, start applying these newer technologies available here in this platform, and also connect to physically with your machines and get the data and push it to the cloud for meaningful maintenance operation. With that, of course, we are providing comprehensive solutions for different cases. And if you have any questions, you can shoot the questions to us now. Over to you, Sweta.
Great. Thank you to Mr. Hariharan for the deep insights. So I hope everyone would be informed with this. So now we have a few questions. So Hari, I will be reading them one by one, and then you can respond to them. So the first question that we have is it possible to do predictive maintenance in Fogwing?
Yes, it is possible. We can do the predictive maintenance. So basically, it's predictive maintenance, right? It's prediction happens based on the data over the period of data. It doesn't happen, just the day you are connecting your machine to the platform. It doesn't predict immediately, because the AI system should understand the data and the trend of your asset to predict something. So the way that we do this implementation by capturing the data, pre-existing data, which may be in the form of manual entry, other things from the customer side, we capture those data, we import through our internal process. Those data get loaded into our AI engine, our prediction engine. And of course we have we have built the prediction engine apart from the OpenAI. So the engine will understand the trend, and we do some kind of data cleansing to make sure accuracy is there in the prediction level. After that, once we connected the physical machines through IoT, then it starts predicting it. So it required a data import into the prediction, train the model for a couple of months to get more accuracy. So it won't happen just overnight because it's all about training the model and getting things done. So it is possible. Yes, we are doing it, but it requires our professional team's involvement on that to quantify the data and to make the prediction more accurate. Otherwise, the prediction will happen, but it won't be accurate if we are trying to do that.
Great. Thank you so much. So moving on to the next question. So the next question is, how many checklists can be created using the Fogwing Asset Plus?
Okay, it's a great question. So you can create a number of checklists, but you should have a credit for that, credit points for that, because every credit point you can create one request and one request from the AI engine. So you need to have a credit points. If you are, let's take, you wanted to create 25 checklists, you should have a 25 credit points. So you need to, if you already have that, you can use it. If you don't have that, you can upgrade it or, purchase more credit points, and then, you can add it into the system. So you can do as much as long as you have the credit points.
Okay. Okay. So the next question is, should we purchase the devices from Factana for machine meter reading?
No need. So as I said in the call, in the middle of the session, so you can bring your own device. You can connect to our platform using your own device and sending the data to our cloud, as long as your device is capable of communicating to our platform through MQTT protocol. So it depends on the type of device that you are purchasing or you are building your own. You can do that. There is no need to purchase from us. However, we are providing very soon we are providing a IoT based asset monitoring kit, which is a combination of sensors and the device with this pre-configured everything for our customer as a package. So you can just buy it, clip it to your asset, and then the data start reading it. And we are reading, you can read the vibration data, you can read the temperature, you can read the current usage, running time, on time, and all stuff. So we are coming with a complete pre-packaged kit for our customers to simply do that instead of taking time and building solution and all. But it's up to you, up to the customer user. They decided whether they can buy a kit from us and use it just like that within an hour, or they can build their own device or purchase third-party device and connect it.
Okay, that was quite an elaborative answer. So yeah, so that was all the questions that we had. Thank you, Hari, for answering them all patiently. I hope the webinar was helpful and the questions that was answered was helpful, not just for the ones who asked, but for the others as well. So now I think it's time to wind up the webinar. As previously stated, we will be uploading the recorded version of this webinar to our Factana YouTube channel. Therefore, anyone interested can visit our YouTube channel to watch this plus the past webinar sessions as well. And for those interested in gaining further insights into IIoT and Industry 4.0 smart factories, we encourage you to explore our blog section at www.fogwing.io/blogs. Additionally, if you are seeking collaboration opportunities, please don't hesitate to contact us at sales@factana.com. So that's it for today. Thank you once again for participating in this session and contributing it to success. We eagerly anticipate connecting with you in our next webinar. Stay tuned and have a very wonderful day. Bye-bye.
Thank you, everyone. Bye-bye.